stresses in soil. On some books, gi-incorporate ni siya nga topic didto pa sa part nga katabi tong volume density relationship. Pero na uban books nga mag introductory part ni siya para sa topic no that discusses sa stresses na yun in our soil mass katong how do we compute for the total stress being experienced by our soil from the foundations no above it or all the structures or all the loadings that are directly above it. So ang kani siyang effective stresses sa atong soil, marag mao pa ni siya ang in situ, no? In situ stresses sa atong soil. Wala pa tara consider diri o kanang mga stresses due to other loadings no or external loadings kay balikan ni siya ang mga stresses are only due to the weight of the soil no soil layers on a certain point and then including the pressure due to water that is existing in or between the voids of our soil. So I will be before we start with the discussion or the solution for your quiz number 8, do you have any questions about the topic permeability? No? So let me just siguro ano lang share the screen for yes for the permeability nga discussion. Ay, wala pa siya na. Sama na siya, no? Our topic is or was about effective stresses in soil. So this part is only the introductory part to the topic stresses in our soil mass na gyud. So as described no in the previous discussion, soils are multi-phase systems. So in a given volume of soil, the solid particles are distributed randomly with void spaces between. So the void spaces are continuous and are occupied by water and or air. So to analyze problems, no, we need to know the nature of the distribution of stress along a given cross section of the soil profile. So we can begin the analysis by considering a saturated soil with no seepage. Duha man ni siya itong i-discuss, no? Ang katong with actually tulo siya, upward seepage, downward seepage, and no seepage. So, ang katong upward seepage, naa siya inlet sa tubig to our soil layers, no? Gikan siya sa bottom. And then the direction of the seepage in the soil profile is upward. And then ang katong downward seepage na ang iyang inlet or na siya source sa tubig no sa babaw niya on the top portion of the soil layer, and then the seepage is or has a downward direction to the bottom of the soil layer. Dito na ito siya na outflow na direction sa atong soil. So nakoy actually you might have wondered, no? For this topic, in situ stresses or the effective stresses of soil, I have had two resources for this discussion because dito sa book ni Brahadas, ang iyahang discussion about effective stresses in soils kay maraming medyo complicated siya no kay actually iya man tong explain gyud kung giunsa pag-derive ang mga formula. Actually present magyapon diri kani siya kanang stresses in saturated soil without seepage pa man siya no kung giunsa pag come up ang formula nga total stress is equal to the pore water pressure and then the saturated nga pressure depende sa kanina ang depende sa situation sa atong soil, or the effective stress is equal to the total stress minus the pore water pressure, or that is the neutral stress, no? Mo to siya ang stress due to water alone. So gi-explain niya dito kung yun sa pag come up, no, ang kanang formula. Total stress is equal to the pore water pressure plus the effective pressure at that point, or the effective pressure is equal to the total stress minus the pore water pressure, or the neutral stress. So gi-discuss lang niya diri ano, so it has been discussed on the pre-recorded discussion. So man yung gingan po din, the total stress, or S, actually ko ano man siya, wala siya nakagdi. If given by the previous equation, can be divided into two parts, no? The total stress is composed of one. A portion is carried by water in the continuous void spaces. So this portion acts with equal intensity in all directions. So muna siya yung pasabot there is ang pore water pressure, or the neutral stress. And the other one, no, it is the sum of the vertical components of the forces developed at the points of contact of the solid particles per unit cross-sectional area of the soil mass, which is we refer to as the effective stress. So, mao gyapon ni siya no, ang katunggyong sa pag-derive ang formula. Kanina na po tayo gamma bar diri, no? So, ang ikaduha nga akong reference is the book by Besavilla, no? The review book for geotechnical engineering by Besavilla. So it is a review book. So when you refer to a review book, no, wala na siya kaayo gina-explain dadto kung giun sa pag derive ang mga formula, ginhatagan niya ta diretso dadto o kung unsay formula gamiton kung kani siya nga situation, no, ang mahitabo. So kung for example in a situation where our soil strata has an underground water table below the ground surface, so meaning gamma dry, no, or the layer above the groundwater table is dry, and then we are asked to solve for the effective stress at point A, mo ni siya kibali ang equation na gamitan. Actually, even sa kanino, we have A, B, and C nga mga situation na nagkandala-ilahi nga mga or lagi nag-varying sa may tawag kanino, varying characteristics for our soil profile. Pareha ra man gyud ang formula nga gamiton ani, or ang concept nga gamiton, ang which is, no, regardless of the characteristic of the soil profile, it is always the effective stress is always equal to the total stress minus the pore water pressure. So the total stress is equal to the stress of everything that lies above that point of consideration. For example, in here, for point A kibali, no, ang makakos og stress iyaha ani is everything that lies above it. So kani nga layer which has a depth equal to each one, and then kani nga layer which has a depth equal to each two. So ang stress is equal to kuan man na siya, no, ang unit niya ana is kilonewton per meter squared, no, kPa. So atong gamiton ana is gamad ang unit weight, no, kani nga situation ang atong gamiton para makakam up ta og kPa, or kilonewton per square meter. We are going to use the unit weight, which is yung unit di ba ana is kilonewton per cubic meter, tapos i-times din mo na siya siyang depth, which is ang unit is meters. So cubic meter sa ubos na meter sa isa, by meter na isa sa babaw, so makancel out ang isa ka meters, you will come up with the stress, no, which has a unit equal to kilonewton per square meter. So basically more man yung concept ana para makuha lang gid mo ang stress ani nga layer, gamiton ni mga iyahang unit weight niya. Unit weight is naman siya cubic meter nga unit sa ubos. So all you have to do is look for a parameter nga na meter nga unit para ma-times nimo siya para makuha ang isa. ang cubic meter may mo lang siya square meter. So mag-ana lang siya ang idea, no. So regardless kung unsa nga layer din na, kung dry ba siya or saturated ba siya or submerged ba siya, basta kay ang pagkuha sa stress anang nga makos anang nga layer will always be equal to the unit weight times the depth. So kung dry siya, di gamma dry ang gamiton, and then ihada yung depth. Kung gamasat siya, kung saturated siya, di gamasat pa ang gamiton. No? So that is common to the different what you call this one, situations of our soil profile, no? Kung ang ground surface, kung ang groundwater table kay nag-coincide sila, no? Ano yung giingon diri is gamma dry daw. Bisag di gud gamma dry, no? Kay kung nalugar ang tubig diri, so ito yung pagka-dry diri nga part kay na-submerged tubig. So marag ko ano na pud na siya, no? Marag self self na lang pud nimo nga marag initiative nga kung gamma dry ni siya. But actually, if you encounter problems like this in the board exam, no, like tricky bitaw ang questions. So you would really have to try two options, no? Kung kabalo basig na sayop lang ang questionnaire, no? Kung ang examiner nasayop lang bagid siya kung nag-coincide bagid ang ground surface o ang groundwater table, and then kung iyang ipagamit bagid is gamma dry or ang iyang ipagamit is ang gamasat. So kung na nga cases sa board exam, you would have to try the two. Kung asa didto ang mo yield og answer nga naa sa choices, then muna to siya bira na. So muna to siya yung pasabot sa examiner. So parang trial and error lang siya kung makita ka ginani, no, pero dili gyapon mawala ang concept nga katong ang pagkuha sa stress is equal to pagkuha sa stress or the pressure would be equal to the unit weight times the height, and then ang effective stress would be equal to the total stress minus pore water pressure. And yung pore water pressure is the pressure due to water alone, no, kay ang yung formula is gamma water lang man, and then imong depth nga gamiton danha is katarbong depth sa tubig nga naa above ang point of consideration. For example, sa kani situation number C, letter C, ang iyahang tubig is H1 plus H2 far from point A, no. So muni siya yang ang muni kibali ang depth sa tubig or the column of the water above, or the height of the column of water above point A. So kung diri na pud ta sa B, ang groundwater table daw is just H2 above A. Ay, ang groundwater. Nadidiri. Bakit ganito? Nadidiri ang water. So, ang the height of the water from point A is equal to H1 plus H2. So, may gamit din. So, diri, ang groundwater table is naalang daw diri. It is below the ground surface. So, it is just H2 above A. So, mo na siya. H2 ra pud yung gamit. So, ana lang siya no. Ang kani mga formula bitaw diri sa effective stress at A, total stress minus pore water pressure ra magina siya per minute. No, dili siya mawala. So, dili na to kailangan nga memorize ni siya, no, ang kaning mga formula sa kada situation or kada characteristics sa atong soil profile. Ato nang yung ibutang sa tawon na una, ang first, ang effective stress is equal to the total stress minus pore water pressure. Ang total stress is equal to the stress, no, due to everything that lies above that point, and then ang pore water pressure is equal to the pressure due to water alone. And then for that, you have to use the unit weight and then multiply the depth of each layer for you to be able to get the pressure. So ana lang silang tulo. So napatay na tawag nga zone of capillary rise. Kani siya it's a special case, no, sa atong soil strata kung naa ba siya zone of capillary rise. So mo ni siya ang ma-add ni siya, no. So based sa katong kuan madugang lang siya. So dili ta magtan-aw, no. So effective stress at dili siya maka-apekto sa point B. Tama ba? right below A. Right below A, which is kani siya. Ay, dili na siya makaabot sa point B. Ang sa maapektuhan sa zone of capillaries, katong right below, kani, for example, right below A, which wherein na siya capillary rise pagid nga. So anyway, so then wala na siya no. So at point B, wala na siya zone of capillary rise diri. So actually, ang muna lang din ni na yung i-consider diri is i-consider na diretso kani nga layer and then kani pod na layer sa A. Ang sa right below A, which is mo yung pasabot nga zone of capillary rise, mo ni siya minus, gi-minus lang nimo kaning stress at A minus kay negative man to ganiya, di ba? Ang formulas ang ato ang pore water pressure or pore water pressure is ano siya, minus man siya. So i-minus lang nimo siya. Minus tas minus negative 9.81 and then minus plus minus pag yun minus plus negative pag dere. So may mo siyang add, actually may mo siyang plus sign, so that will add to the effective stress at point A kung dili ka mag-consider sa zone of capillary rise. So di na to libugan tong self no, kung makabasa na tag zone of capillary rise, automatic mo incorporate tag inani nga equation no para ma-solve ang effective stress ana nga point. So, ang kani pang effective stress of saturated soil with upward seepage o katong downward seepage, wala ang kay siya kalainan no. Ang the same lang yun ang concept sa total stress, pore water pressure, effective stress. Diri lang is nagamit siya aning mga pressure head bitaw diri when you are going to insert a piezometer no in each of the layer, ma-add lang siya. Kay since naa may another amount of water being incorporated into our soil layer, so that will basically add to the stress no experienced by our soil on that specific point no manang day sa mga formula ma-add lang siya. So ma-add lang din siya. Depende sa kung asa nga layer ka consider. Kay kada layer naman pwede i-insert nga tagsa sila ng piezometer, so you can have a reference for each point. So ma-add lang siya sa total depth. Actually, di ba siya depth no? It's the total pressure head. Yung H1, H2, and then H kani siya. Madugang lang yun siya. And then ang dugang pagid is ang seepage force per unit volume, which is equal to this one. F is equal to I times the gamma water. I is the hydraulic gradient. So, ana lang siya. The same nagyapon sa downward seepage. Ang kalainan lang is ang situation or ang movement sa water within our soil data. So, ang kaning with no seepage, same ni siya sa itong previously discuss atong ganihan. No? Kani siya, nga discussion is from the book of Besavilla. And then, ang katong pinakauna nga part is by Brahadas. So, parehar gyapon siya concept, no? Sa total stress, pore water pressure, o sa effective stress. So, one sample problem, and that would be all, no? For the topic, effective stresses in our soil. So now, let us proceed to the discussion of the solution for our quiz number 8. So allow me to share. Ay, by the way, naapabay wala naka-take sa quiz. Actually, di pa man siya close ang quiz, makuan pa siya, ma-access pa siya. Pero so katong wala pa naka-take, kindly inform me para di pa ta mag-discuss. No? Wala na ba? Nag-take na ba ang tanan? Okay, so I am assuming nga naka-take ng tanan, no? So ako sa siyang i-close ang quiz. Alright, so na-close na ang quiz, no? So now it is time for us to discuss the solution of the quiz. So we have just 3 problems there, and we have 3 questions in each. So I hope makita ra siya, no? Asa ba to? Okay. So, kani siya nga question or ang katong sa inyong quiz is actually from the book of Besavilla gid siya, no? So basically, inani gyud ang itsura sa gawa sa board exam somehow. So, inanam yang sa board exam, no, na isa ka scenario, and then naituludan ka question sa para ana nga situation. So actually mas arang-arang na lang siya, no. So first, the number one problem for our quiz number 8 says that a thick layer of clay underlies a sand formation having a thickness of 5 meters. Pero usually, no, sa mga inani manggod, na siya most of the time, na siya illustration. So, pero kung, for example, kanilang siya nga statement, so, magbalay-balay pa ka nga, yung siya na kunoy, a clay daw underlies a sand formation having a thickness of 5 meters. So, malibog ka kung unsa asa ang thickness sa clay ba or sa sand. So, muna siyang nasa illustration diri. So, the groundwater daw is located 2 meters below the ground surface. Specific gravity of the sand and clay is both 2.65, with the sand having an average void ratio of 0.52. The clay has a water content equal to 42%. The number one, we are asked to solve for the saturated unit weight of clay. So, balik lang gyapon ta didto, no. So this is the solution. Balik lang gyapon ta didto sa ato ang volume density relationship nga mga equation, no. Unsay applicable didto nga gamiton so that we can solve the value for our gamma sat using the given values for the specific gravity and the void ratio, no. So first, since may itong formula, no, the saturated unit weight of clay daw, and then may itong formula ang gamiton. So we basically need the value for our specific gravity and our void ratio, kay no naman ang gamma water, no. So ang kaning E, we can solve it from this equation, no. This is the equation for the degree of saturation. Kaya ang clay man daw is below the groundwater table, meaning it is saturated, no, equal to 100%. Na kay na-submerge man siya sa water, no, marag nahulom gid siya sa water. So ang amount of water didto is equal to 100%, kay nahumol man gid siya, no. So therefore our degree of saturation is equal to 100% or 100, and then the moisture content is equal to 42%, which is given in the problem, and then the specific gravity, which is also given no, the value of 2.65, and then we can solve our void ratio, no, this one. So our gamma sat for the clay is equal to 17.47 kilonewton per cubic meter. So rare na kayo, no, ang cases ngayon aning ipasolve pa tag gamma sat, pero kailangan na gyapon ta maghanda gyud so in cases like we would be asked to solve for the gamma saturated for our layer. All right, so the second one being asked in the problem is the total stress at a depth of 10 meters. So asang 10 meters, below the ground surface. So basically this is here. Basically this is here, no. So ang mag-contribute sa total stress ay nga point that is pinakaubos, no, that is the below the 5 meter depth na sa clay layer. So basically ang stress nga ma-create din na point is the stress due to this layer, no, due to this sand layer, and then plus the stress due to this clay layer. So first we have to solve for ang sabat ang kailangan para makuha ang total stress, no. We should be able to know first the unit weight of each layer, and then second the depth of each layer. So ang depth given naman siya problem, dito namang problema no. Ang ato problema nang diri is ang unit weight kay wa yun siya naghatag unit weight. Although in the previous problem or previous question, gipangayo na niya ang gamma saturated sa clay. So na natin value sa atong gamma sat sa clay. Karon pangitaon na pud nato ang kanina ang unit weight sa kaning layer no, kaning above sa atong groundwater table kay kaning everything that lies below the groundwater table is considered saturated man no. Wala siya giingon nga dry daw ni sand diri, pero kita na lang mag-initiate ba murag minganta nga kung wala siya nalabot sa tubig no, kung ibabaw siya sa tubig meaning dry siya, wala siya nabasa. So we have to have another unit weight for this one because surely lahi yung unit weight ani nga layer compare sa kaning layer nga na-submerge atong water no. So dili pud ta kaingon nga the same ra no ang unit weight sa kaning sand nga na-submerge o kaning clay nga na-submerge kay lahi man sila og specific gravity ay lahi sila void ratio rather lahi sila og void ratio lang specific gravity is just the same. So we have to have another unit weight for this sand layer nga na-submerge atong water. So basically, we have three layers in here that have different characteristics. First, ang kaning sand layer above the groundwater table. Second, the sand layer below the groundwater table. And then the clay layer, no? So we have 1, 2, 3. So first, we are going to solve for the gamma dry, which is the unit weight of the sand above the groundwater table. So kanila tong gamiton no, given man ta og specific gravity and then the void ratio, so we can compute directly the value for our gamma dry. And then for the gamma sat as well, kay given naman po ang value sa atong specific gravity and the void ratio, we just can directly compute for our gamma saturated for the sand no submerged in water. So therefore, the total stress at a depth of 10 meters below the ground surface would be equal to 17.1 times 2, which is due to this layer, plus 20.46 times 3, which is due to this layer, plus 17.47 times 5, which is due to this clay layer. So therefore, the total stress at 10 meters below the ground surface would be equal to 182.93 kPa. So the last one being asked is the effective stress at a depth of 10 meters below the ground. So effective stress is just equal to the pore water pressure or the pore stress or the neutral stress sometimes ang tawag sa iyahan. No? So we just have to substitute ang pore water pressure, the pore stress just in here, or the neutral stress is equal to the gamma water times the depth of the water no above or the height of the water above our point of consideration. So from the total stress, which is equal to 182.93, we just have to subtract 9.81 times 8, no? And then we would arrive with our effective stress, which is equal to 153.5 kPa. All right, so this is our question number 2, or problem number 2 rather. So we have here a soil profile given in this figure. So you have 3 layers and it has a zone of capillary rise. So first we are asked to solve for the effective stress immediately below A. So meaning this zone of capillary rise. Apil siya din, no? So first, we have to know, di ba, atong bantayan nakauna is kung naabay mga unit weight kada layer and then kung naabay mga depth kada layer. So kung may mga depth na siya din given man siya. So atong problema na lang is ang mga unit weight. So wala yung given ng mga unit weight. Ang given lang is ang specific gravity ng mga void ratio. So we can directly solve for that man sand. So for this dry sand, we have to solve for asa matong point A. Muna siya. Effective stress immediately below A. So diri daw nga part immediately below A. So diri so unsa man ang stress nga naka contribute sa iya no, so meaning kaning naa sa babaw kaning dry sand and then Tapos kay since gi-emphasize niya diri no na sa zone of capillary rise, so mag-minus negative na punta nga poor water pressure due to this zone of capillary rise. So first, gisa niya pag-solve diri be. So ang gisolve niya pinakauna ang unit weight dry for this layer kay wala man siya gihatag no. So muni siya nga part diri. Gisolve pa niya ang gamma dry and then gisolve pa dayon niya ang total stress above level A. So muna narang A na to diri no. Muna siyang 17.4 which is this one, the unit weight dry, times the depth equal to 1.5 to 1.5 man siya diri no. And then the poor water pressure due to zone of capillary rise which we are going to subtract. No, subtract mo gid siya kay although ma-add siya later on kay negative man po ang sign aning atong poor pressure due to zone of capillary rise. So ma-add ra gyapon siya no. Pero minus negative poor water pressure gina siya dapat ang gamiton. Kay lalay po siya nga case. So mo siya no, that is equal to 26.1 and then gi-minus dayon siya aning due to the the poor water pressure due to zone of capillary rise which would be equal to 0.42 times 1.75 which is the depth times the gamma water. No, ang 0.42 is the degree of saturation. So that is the S. So the effective stress immediately below A would be equal to 33.31 kPa daw. So the next one being asked in the problem is the effective stress at point B. So that's point B din no. So dili na siya dili na siya maapektuhan sa atong zone of capillary rise. Pero maapektuhan siya ning layer ha, note the difference. Ang at point B, dili siya maapektuhan sa zone of capillary rise, pero maapektuhan siya ning layer equal to 1.75. Pero di na ta mag-minus sa poor water pressure due to zone of capillary rise, pero maapektuhan ni siya ani nga layer in general. Pero di na siya mag-subtract, no? Dito ra siya right below A, nga din ang part. So, at point B, unsa may makaapekto sa atong point B, no? Sa kani nga layer, which is equal to 1.75 nga clay and then 1.5 nga dry sand. So, kabulo naman ta sa unit weight ani nga layer, no? So, kana na pag nga layer ang atong problemahon. So, yes, we are given the degree of saturation which is equal to 42. Then from that, we can solve the moisture content and then solve for the gamma moist. So, kaya siya nga maagi diri. Depende na lang, no? Depende na lang sa imuha kung unsa nga formula imong gamiton, no? Ang pag-compute sa gamma moist or yes, the moist unit weight of this layer, no? Kay kani man gud siya ang pag naay zone of capillary rise, dili ka makaingon nga gamma sat siya or gamma dry, no? Kay naman siya ang diba ang capillary rise is due to the naman siya water dinhi, no? That is due to the water. So meaning moist lang siya with the degree of saturation equal to 42%. So depende na lang sa imuha no kung saan yung pag-come up sa kani nga unit weight ani nga layer yes, kani nga layer. So therefore, the effective stress at B would be equal to the 17.4 nga unit weight aning dry sand times 1.5 nga iyang depth plus the 16.96 gamma moist nga mo unit weight aning clay layer diri times 1.75 nga iyang depth. So the effective stress at B would be equal to 55.78 kPa. And the last one being asked for this problem is the effective stress at point C. So that is basically everything above point C. So wala gyapon given nga wala gyapon given nga unit weight saturated sa ato ang clay layer of 3 meters depth. So so the effective stress at C is actually mura man siya og domino effect, no? So from kaganiha sa previous problems gipangayo naman ang effective stress dere of dere. So we just have to add that one. So we can directly use the effective stress at B plus sa kaning layer dere ano effective stress sa kaning layer. So mo yang gibuhat diri that is from or after being able to compute for the gamma saturated or the gamma sat using the given values for our specific gravity and the void ratio. Iya din gisolve ang effective stress due to this layer, no? Kaning kaning 18.46 minus 9.81, this is the gamma sat minus gamma water, di ba? This is the gamma prime, no? And then i-times nimo siya sa 3 meters ngayang depth. So kani siya nga part diri, it will yield directly the value of effective stress due to this layer alone. And then if you're going to add that with the effective stress at B, no? And then muna siya ang total stress or total effective stress at point C, and that would be equal to 81.73 kPa. So in addition that I note to that, kung when you're going to consider a layer with zone of capillary rise, it would be much advisable na you really have to use the gamma moist, no, for or that is the gamma wet gamma wet nga iyang unit weight kay mo siya usually ang ginagamit kay murag di mo ka sure pero di siya certain, so that is why you are going to assume it to be moist lang sa morning. Pero siguro in other cases kung di niya makuha ang answer ana, siguro you would really have to try using the gamma saturated for that layer. And then if that is what going to give you the answer that is found in the choices, so maybe you can use that one. So in this problem, you're advised to use the gamma moist of that layer to come up with the answer for the effective stress at B. So the last one is about no the effective stress for a saturated soil with downward seepage. So kung downward seepage, ang pasabot-an ang flow or ang source sa water is nas babaw sa soil layer, no? So mo ni siya inflow niya. So kung bisan pag dili niya ingon diri no nga nay downward seepage, pero as far as we can see in the illustration nga sa babaw ang inlet sa water and then downward ang pagsunop sa atong tubig out from our soil layer, then automatically that is a downward seepage, no problem. So we have here the figure shows a granular soil in a tank having a downward seepage. So the water level in the soil tank is held constant by adjusting the supply from the top and the outflow at the bottom. So the void ratio of the soil is 0.47 and the specific gravity is equal to 2.68. We are asked to solve first for the effective stress at point C. So since at point C. So nara siya diri no. I hope makita na to siya no. So kani siya nga layer diri wala gihatag na sad no nga value for our unit weight. So therefore we still have to solve for the value of our gamma stat using the given values of our specific gravity and the void ratio. So at point C, unsa man ang naa nga makakuha sa iyang stress, ang kaning layer or depth of the soil equal to 4 meters plus the water above it, no? So therefore after being able to get the gamma sat no of this layer, you're going to solve for the total stress at point C. So the total stress at point C would be equal to ano ni siya, wait okay. Okay, so back at it again. The total stress at sea would be equal to the stress due to this water above, which would be equal to the gamma water times 1 plus the pressure due to this soil layer above it, which is equal to 4 times its unit weight, which is equal to 21.02, and then you would come up with the value for the total stress at sea, which is equal to 93.89. So for us to be able to get the effective stress at sea, kaning total stress minus dapat na to siya og pore water pressure, and the pore water pressure at sea would be equal to the depth of the water above point C times the unit weight of water. So ang kani siya kaning yes, oo. Napaday siya kuan na siya imong i-consider diri nga pressure head from the piezometer inserted at point C. So mo ni siya ang kalainan sa mga problem nga yes. May siyang problem nga na IC page ayaha. So ang gito ta ang changes may tabo sa pag-compute sa tong pore water pressure. So instead nga i-add lang ta nimo ni siyang duha, no? Kaning duha ka depth diri and then times nimo sa gamma water. Since naaman siya pressure head, no? Diri due to the seepage of water within our soil. So you have to incorporate it into the solution. So you have to subtract 0.6, no? At point C, mo ni siya yung piezometer. And then, naa daw siya drop nga 0.6. So you have, that's why you have to um, subtract that one from the total height, no? Diri. Kay paubos man siya. Pero kung saka to siya, pwede mo siya i-add. Kung kay paubos man siya diri, so that's why you have to subtract the 0.6 H diri times the 9.81 unit weight of water. And then after being able to compute for the pore water pressure at sea, you just have to subtract that from the total stress, and then you would come up with the value of your effective stress at point C. So in this case, it would be equal to 50.73 kPa. So the next one being asked in the problem is the effective stress at point B. So point B na siya diri So the total stress at point B is basically equal to the stress due to this layer of water and then due to the stress of the soil layer above our point B. So that would be equal to 9.81 times 1 times our gamma sat for this layer which we have previously solved, no, which is equal to 21.02 kay same raman og soil layer situations ato ang C ug B no points, no. So same lang ang gamit sa atong gamiton diri So that would be equal to 21.02 times 6 nga iyahang depth. So that would be equal to 135.93 kPa total stress at B. So now, for us to be able to get effective stress, we just have to subtract the pore water pressure from the total stress. So for the pore water pressure at B, that is 1 plus 6, which is the depth of the water, no, above B, minus the 0.9 na po diring drop sa atong head at due or from the piezometer inserted at point B. So minusan na to siya 0.9 diri. So our pore water pressure now would be equal to gamma water times 1 plus 6 minus 0.9 kay drop man siya from this level, no. So may nang minus siya din So the pore water pressure at B would be equal to 59.84. And if you are going to subtract that from our total stress at B, we would come up with the value of our effective stress at B, which is equal to 76.09 kPa. So the third one being asked in the problem is the critical hydraulic gradient, which I did not include in the quiz kaya dili man gyapon siya maka-contribute no sa solution. So ang ikatulo nga problem dito sa inyuhang quiz is or ang ika-third nga question para sa problem number 3 sa inyong quiz is just the downward seepage force per unit volume. So kanila siya nga part, no. So dili ta mag-consider diri nga solution. Although ako siya ipakita kay apil mo gid siya dito sa katong kuan sa book ni Bisabilia ba. So wala din na ta siya labot, no. Kani siya diri nga part wala siya labot. Diretso ta diri sa number 4. So the formula for the downward seepage force per unit volume is kani man siya, no. F is equal to I times gamma water. So ang atong pangitaon na permit is ang hydraulic gradient or the I, no. So for us to solve for the I, since it is not given, it is 0.9 times divided by 6. So that is rise over run. So ang flow sa atong water is basically from this point down to this point, no. So meaning mo na yang gidaganan, which this is the run. This is the run of our movement of the water within our soil profile. And the height or the rise for that is the head, no, or the pressure head at that point, which we can get from the piezometer inserted at that point. So the rise is 0.6, and then no, the rise is 0.9, 0.9, the 0.9, and then the run or ang ginaganan sa atong yuta within our soil is equal to 6 meters man, di ba? So that is our run. So rise over run, kung atong hydraulic gradient, no, 0.9 over 6, that is equal to 0.15. And if you are going to multiply that with our gamma water, which is equal to 9.81, you will come up with the value of your seepage force per unit volume. So force siya per unit volume. That's why in ani ang unit, no, kilonewton, which is the force per unit volume. So nagipon siya cubic meter. So it doesn't mean na inani ang yahang unit kilonewton per cubic meter is unit weight siya, pero kani nga case seepage force siya, force per unit volume. That's why inani yahang unit. So that would be all, no, for our
Excuse me, ma'am.
yes.
Murag, ang given sa quiz, ma'am, kay lahi.
Ay lahi ba?
Ang specific gravity niya, ma'am.
O sige, wait, let me check ha. Mm, ang specific gravity is 2.86 pero dapat 2.68 siya.
Yes, ma'am.
Oh my goodness. Nasayip siya. So siguro I will just malihipod ang kuan ato, no, ang choices. So giunsa lugar to ninyo?
Ang closest na value, ma'am.
Closest nga value. So unsa man ang inyong answer gibalida ni sa kuan?
55.5 o 83.3.
Okay. So namali gid ni siya, no. Ano ko na siya nabantayan 2.86, dapat 68 di ay ni siya.
Mao
Siya
dito, ma'am.
nabantay. Wala niyo
Ah,
nakuha.
Dayon sa number 3, ma'am, murag wala sa choices ang answer.
Ay wala pud mo kakuha sa ang kaning
Same
1.47.
tag answer, ma'am, sa item number 3.
Oo, pero
Pero wala
wala
siya
siya
sa
choices.
choices.
Unsa man ang choices? 1.47, 1.88. Na may 1.47. Ay, let me check the Google form daw, be.
Ma'am.
Ay, naa siya. Number 9. Letter A. 1.47 kilonewton per cubic meter.
Naaman, ma'am. Naaman.
Ay, naa siya. So, kanina lang, kibali, no, ang i-bonus ka na lang ning kuan, number 7 ug number 8. So, I really apologize for the mistake for this one, no, nga 2.86 mo kung nasuwat ko dapat.
Lagi, ma'am. Abi na mo gituyo na siya, ma'am, nga 2.86, ma'am. Kay wala man gud ang answer sa choices mo.
Ay, okay. So, kung gusto ko kabantay nga 2.68, 2.86, di ako na-type. Oh my goodness. So, siguro, ako na lang ni siyang i-bonus, no? So, basically, mamaynusan ni siya 2 items. Our quiz will just be equal to, pila man ka points? 6 points. So, mahiman lang siyang over 21 ang perfect score. Pero, ang kaning, ano yung pila may score ninyo? Ano yung nadyo din naka-perfect. So, meaning, na naka-perfect dyan sa inyo 21. Per night, 24. Kinsa ning 24? Nasakto niya ang downward seepage force. So, anyways, mano to siya, no? So, thank you so much for correcting me, no? So that I have been informed with the mistake in the questionnaire. So, mura makatatong question sa quiz number 8, no? Kinsa tong nag-ingon ka ganiha? Di lang ako nakita ang ngalan. Kinsa ito?
Ako, ma'am.
Ay, si Neil. Okay, thank you so much, Neil, no, for informing me sa imong nabantayan nga sayop na to. Instead nga 2.68, 2.86 ang akong nabutang. So, inis, dili ta mabalaka, no, kay the perfect score for that one would be equal to 21. Di na siya 27. Tama ba? Yes.
Thank you, ma'am.
So, that would serve as a bonus na lang siguro because it's my fault man sad that I have made a yes. So, nasayop pa dito nga part. So, yes, sayop gid siya. Akong kita na 2.86 gid ako nang butang. So, anyways, aside from that, do you have any more questions before we dismiss? Ma'am, ang number 3 po, ma'am. Number 3 nga sa problem number 1, okay, tanaw na ko ha. Compute the effective stress 153.5. Unsa man ang question ni mo dari? Wala gyud pa sa choices? Na siya letter A. 153.5 man siya. Let me check. 153.5. Na siya sa choices ay 104 ang answer if i-solve, if i-calculate ang ay mao? Sige daw, B. Anyone in the class who have the same concern sa kaning problem number question number 3 for problem number 1? 104 siya. Ako di calculate. Ay, oh my God, bakit? $104. Yes, 104.45 dapat siya. Nga naman. Wala, uy. Nagsalig-ligig ko nga kuan siya ay tama, 104.45. So, kinsa man ang na-derive. Nga naman sad 8 niyang times. Okay. So let me check your answers. Let me just go to the pero daghan kaayo like 93% sa inyo ha ang nakakuha ang kuan. Saktong answer gyud sa ninyo ang kan number 3. Nga dili man yes.
Siya ang closest pod, ma'am.
Ay, close. Oh my God.
Closest targapon, ma'am.
Closest ra gyapon. Hello, so dapat gid i-review na ko yung mga questions sa kuan. Closest siya sa 145, 104.45. Sige. So, mahimo na lang gyud siyang yun sa manibi, -4. So, mahimo siyang I'll just highlight it kay para makuan ako. Katong 7 ug ang 8. So, mamaya sana pa check isa. So anyways, there are just two of you who are not able to get question number 3. So, I'll just adjust siguro your scores for this one. So, yes, 27 out of 29. Abot nga ang 29 ra mo ay. Pero, sige lang. That is 27 out of 29 nang nakakuha og sakto nga answer ani number 3 no. So tumpak ta diri nga part nga closest atong gikuha. So actually yes, thank you so much for the correction no Kim. Kay nagidi siya mo sayo. So anyways, I apologize for that. So next time I'd make sure nga so, siguro next time, I'll make out for that. So, actually, na nga mga cases magkakahitabo i-first board exam ay kanabit ang walas choices ang answer and then ang closest na lang. Kay mabalaan man na after the board exam, for example, after sa GTech na subject, magingon mo, wala lagi to sa matimanan mo gini man sa board exam, matimanan nimo ang question nga wala sa choices ang answer. So, mabalaan nimo nga dili ka alone, dili ra ikay kabantay. Hindi ko mag-compare nimo sa imong classmates later on. So, mura ba to? Okay, mura matingali. Okay, so any more questions or any more corrections regarding the quiz number 8? So, murag wala naman tingali, no? Okay. So, that would be all siguro for the effective stress in our soil. So, the next topic would be about stresses in our soil mass. Now, how does our soil react or what are the stresses that our soil will experience in cases like naa siya'y load sa iyang ibabaw, like kung point load ba siya, kung uniformly distributed load ba siya, or kung other types of load ang nasa iyang ibabaw. So, that would be on next week, Wednesday. No? I will be posting the lecture notes and pre-recorded discussion for that. And then the same as the other modules that I have posted, NAPJ quiz. So, any more questions before we end? Magulat naman tingali, no? So please turn on your camera for a while so we can take the class picture for this session. So thank you so much for all your corrections, no? I really appreciate it. So I hope next time less na ang correction. Okay, so mag-smile na ta in 3, 2, 1. Smile. All right, so that would be all. Thank you so much. No, I hope you have learned something about effective stresses in soil. Okay, magawas ko just board exam. So, kung wala na questions, the class is dismissed. Have a great rest of the night and keep safe. Bye-bye.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank
Thank
you're
you, ma'am.
welcome.